So excuse the mess, you're in my study. Always disorganised. Well, organised, disorganised. So, as standard, the filament spool sits on a rod, goes through the spool sensor and into the print head. And I deliberately got one that's got the feed in the print head, not a Bowden cable going somewhere else, so it does actually drag it. Now normally this works absolutely fine. Occasionally there's a bit of drag here and it just causes a few problems even with PLA. What I've been finding though is when I'm using the TPU, and I've got 3 grades, the 95 is okay. It's not too elastic, so it will pull through the sensor and come off the roll. I have some 82A that is quite a bit more flexible, and if I feed that through the sensor there's too much drag, and instead of the spool turning it just ends up stretching, and sometimes even with it just sat on the drum at the back, the friction is enough to produce some drag and stop it printing properly. And then I have printed successfully with some 70A, but this is extremely elastic, and so any friction here at all on there and it just starts to get longer and longer and doesn't print. So the times I've used this, and mostly this one, I've had to babysit my prints, and as the spool's taken up the slack I've had to introduce some more slack so it can print. And the problem seems to be, well, threefold. One, the friction going through here. Well, I can bodge that by just putting a piece of filament through and it won't ever go. Two, the friction of the spool on the plastic tube. It's knurled or rough finish to provide less friction, but there's enough drag there that it doesn't really help. And three is that the arm is out at the back, so the filament has to come forwards. So what I have been able to do is turn the arm round, about, click it into place and get it to fit on the back here. So now, even with this one in, we've got a direct feed straight at the arm. However, we've still got the friction. So what I thought was I would design something that would take the friction away. So I've measured the old spool, drawn up a new spool. You can see the section at the bottom that clips into the spool holder, and the section at the top, which is a long thin shaft, which is the internal diameter of the bearings that I've got. You can see the 2 notches there, so it'll screw in, and then a hole at the end so I can attach a screw to stop the drum falling off. And then the final spool holder, print out 2 of these. You can see the tapered section that will go into any size spool in the middle, and then on the other side there's a recess that will take the bearings that I've got. After a few iterations I have got this with, I've copied the locking mechanism and done it so you can put this in, lock it in place, and that gives a small spindle, and then onto the spindle put some bearings in a couple of spools so they can spin freely on the spindle. I'll cut to some other video. So Mark 1 spools designed for the PLA. So the PLA sits on there, the bearing sits on there, the shaft runs through there. Of course, what I didn't think was that there isn't a standard size for the filament. So all the rolls of filament I've got are a different size. But my first version just fitted in the diameter of my PLA. I thought, well, I can make it stepped to fit the ones I had, and then with a little bit more thought, I've put a taper on so the spindles will fit from a maximum diameter of one size to a minimum diameter of another size. And this, like I said, just fits in, turns round, locks in place. The bearings will enable it to run. I've just got to find, I want to find a little spring for the end so I can hold it in place, and then I'm going to use the screw just to apply a little bit of compression on there just to hold the drum in place. This is the 70A TPU mounted on the spools. Runs freely now, dropping straight down to the extruder with its, what do you call it, a track feed. The sensor has got a piece of PLA through it and wedged out of the way. I've just started printing a job. So this is about half an hour later. The print's moving. It's tautish, but it hasn't jammed, it hasn't stretched. So far, that's a win. So, spool's still standing, cable's gone through, filament's gone through, the print has printed. 100% infill TPU 70A, quite soft and squidgy. Sorry I didn't take any video, but this is the same thing with the 82A Shore hardness. Again, printing well, printing without any problems, the filament not catching. So here we have one of my CAD designs for the rubber tank supports on my Motor Marini 250. It's just a round design, slightly tapered with a domed top, and then there's a recess in the middle which fits onto a spigot that's bolted to the frame. To get it to an STL file, I just export it as a stereolithography file. But what I haven't been doing is changing the tolerances, and it was only a couple of weeks ago I found that by changing these, it much improves the quality of the STL file, so that when I import it into the slicer, you don't get the little facets on there. Original ones without the STL parameters adjusted, newer ones with the STL parameters tweaked, as I found on the internet. You can see you haven't got the facets on it. It's a lot smoother, a lot rounder. Can't believe I've been using it nearly 2 years and only just discovered that.